Class diagrams. What is a class? A class is a blueprint for an object. Object exists because of classes. And the entire point of object-oriented design is not about objects. It's about classes, because we use classes to create objects. So a class describes what an object will be, but it is not the object itself. In fact, classes describe the type of objects, while objects are usable instances of classes. Each object was built from the same set of blueprints and therefore contains the same components, including properties and methods. The standard meaning is that an object is an instance of a class and object. Objects have states and behaviors. Let's see an example. So we have the bank with some attributes, code address, and some methods, manages and maintains, and the customer, which has the properties name, address, job, and the method ons, where plus means public. A class represents a concept which encapsulates states or attributes and behavior operations. Each attribute has a type. Each operation has a signature. The class name is the only mandatory information. The classes are depicted as boxes with 3 sections. The top one indicates the name of the class. The middle one lists the attributes of the class. The third one lists the methods. Abstract operations. Unlike attributes, operations can be abstract, meaning the class provides no implementation. Italics indicate abstract operation names. A class that does not have an implementation for an operation or method, either through inheritance or by providing one itself, is considered an abstract class, and its name is italicized. You cannot create an instance of an abstract class. However, they can be subclassed to provide implementation details. A purely abstract class, one with no methods at all, is similar to an interface, except that it may have attributes and participate in generalizations with other classes. Class visibility. You can use the plus to identify the public attributes or methods. Use minus to identify private attributes or methods, and use hash to identify protected attributes or methods. Attributes. Attributes are shown in the second portion. The attribute type is shown after the colon. Attributes map onto member variables or data members in the code. Methods. The return time of a method is shown after the colon at the end of the method signature. The return type of method parameters are shown after the colon following the parameter name. Operations map onto class methods in code. Parameter directionality. Each parameter in an operation or method may be denoted as in-out or in-out, which specifies its direction with respect to the color. This directionality is shown before the parameter name. Perspectives of class diagram. A diagram can be interpreted from various perspectives. Conceptual represents the concepts in the domain. Specification focus is on the interfaces of abstract data type or ADTs and the software. Implementation describes how classes will implement their interfaces. The choice of perspective depends on which phase you are in the development process. Design model development will typically start with heavy emphasis on the specification perspective and evolve into the implementation perspective. From conceptual to implementation, the amount of details and relationships increases. The class name is the only mandatory information. Conceptual bank and bank without anything. or bank with attributes and methods. Conceptual. Specification with more details. Implementation, also type, and so on.